The ice has always been here. We've never known a world without it. Throughout our past, we've always had a close relationship with ice. So what's the future of that ice? And what might it mean for Earth and for us? Greenland is covered in the second largest ice sheet on the planet. On the west coast is the massive Jakobshavn Glacier. It has become the front line in our attempts to understand what's happening to the world's ice as global temperatures rise. I'm just the latest in a long tradition of scientists who have come here to poke, probe and measure the glacier in the name of science. The first was a Dane, Henrik Rink. Now, he was the first to realise that the glacier came from snow that accumulated high up on the top of Greenland's vast ice cap. Now, ever since our Mr. Rink, scientists have come here to monitor the state of the glacier. And as a result, we've got a pretty good record of what's been happening here for the last 150 years. Until as recently as 1997, the glacier was relatively stable. But in the last 10 years, it's changed dramatically. Seen from space, the glacier is on the right, and the fjord which it flows into is on the left. And you can see that it's retreated massively by 10 kilometres. But the reason it's retreated is not simply because it's melting in the increased temperatures. It's because the glacier has speeded up. It's now moving at 40 metres a day, and this has made it much thinner. The result? The front of the glacier keeps breaking off into the fjord, leaving it jam-packed with icebergs that are floating towards the sea. Filmed over 3 months, you can see just how much of Jakobshavn's ice is floating away. These are worrying signs, and they're completely changing our understanding of Greenland's ice. It may not be only Jakobshavn Glacier that's disappearing so fast. There's other glaciers along this coast that are also accelerating. The problem is, if glaciers continue to retreat at this rate, it could lead to the eventual disappearance of all Greenland's ice. That's 10% of the world's total. That would raise sea levels by at least 7 metres, which would flood many of the most highly populated regions of the world. Florida would be one of the worst places to suffer. The northern coast of Europe would be barely recognisable, and much of London would disappear beneath the waves. So, not surprisingly, scientists are eager to find out what's going to happen to Greenland's ice as global temperatures continue to rise.
Well, the landscape is very special, as you can see, and on top of it, it never gets dark.
Yeah, I know, the sun's fantastic. I've joined up with Connie Steffen. We're on a part of the ice sheet that's connected to the Jakobshavn Glacier. Connie's trying to understand what's causing the ice to speed up and break off into the sea, and whether it's related to climate change.
The ice moved fast, at first by 10%, then by 2002, 30–40%, and it produced more water, like this river. And this water is probably the explanation why the ice here, it starts to move faster.
Each summer, as a result of rising temperatures, more and more meltwater is forming lakes and rivers on the surface of the ice. And this is where all the water flows, into deep shafts called moulins. No one knows for sure where the water ends up when it disappears into the moulins. But Connie believes it flows straight to the base of the glacier. If he's right, This could explain why the glacier is moving so fast.
Water is heavier than ice, so it will push itself under the ice and lift up the entire ice sheet.
So this water here dives down to the bottom of the ice sheet, lifts it up, lubricates it, and allows it to move really fast.
If you have a water column that goes all the way down.
So far, no one has been able to prove if the meltwater actually does reach the bedrock and lubricate the ice sheet, or if it simply flows through the ice, never reaching the bottom at all. Now, Connie and his team hope to solve this mystery. They're going to drop a camera deep into the ice to trace the route the water takes. It's the first time anyone's attempted this.
Is it heavy?
Very heavy, actually.
They're using a camera built by NASA, designed to withstand freezing temperatures. It could finally answer the question of whether the increased amount of water is actually speeding up the flow of ice. If it is, then he will have made a direct connection between climate change and the disappearing glacier. The moulins are full of tight twists and turns, so to help the camera get through, they've chosen the biggest moulin they could find. There's no water running into it at surface level, but they know there's plenty down there because they can hear it. It's a precarious business. For a start, I'm not sure how thick this overhang of ice is.
Stop.
But it looks as if this is all undercut here.
It is undercut, that's why we are on the road.
All right, okay.
If we go down, we hang on the road.
All right.
And our colleagues take us out again.
All right, okay. I trust you.
Don't worry, Ian, don't worry.
So this is the first time it's gone down a natural
This is a
moulin.
first. And maybe a last. Don't worry.
They've got 1,000 metres of cable, which Connie believes is long enough to lower the camera all the way to the bedrock.
meters.
This is amazing.
70 meters.
70 meters.
Whoa, what was that sound?
Oh, these are walls falling down and the cave collapses.
That's what I was fearing, yeah.
This is pretty safe, right?
I think so.
Okay.
There we go. Now we're submerged. Wow, look at that.
Finally, 90 metres down, and we've reached meltwater.
Now it's a lot, yeah.
It's a good sign that the camera's on the right track. But if this water does reach the very bottom of the ice, there's still a long way to go.
50 degrees. I think it's stuck. Stuck on a wall. Is it getting snagged, do you think?
The camera seems to have reached a bend in the moulin, and it's not moving.
It's hit a ledge.
Pull it back. Right now the camera is where the water flows horizontal away.
Yeah. But our camera's kind of stuck there.
It's either not enough water to drag it, or the camera is too heavy.
Yeah.
It could be just a kink in the moulin, or it could be the water never reaches the bedrock. For the moment, it will have to remain a mystery. Connie and his team will have to redesign the camera and return next summer. But wherever this water ends up, it's clear that more surface ice is melting. Scientists have mapped the area of the Greenland ice sheet that experiences surface melting in summer. As recently as 1992, it was a relatively small area around the edges of the ice sheet. But by 2005, the melt zone had massively expanded. This would be bad enough on its own. But if the meltwater is also causing the glaciers to accelerate into the sea, it could have very serious consequences.
There seems to be no doubt that Greenland's ice is moving and changing faster than we ever conceived of even 5 years ago. What's more, because this process continues every summer, the whole ice cap loses elevation, which means that it'll be sitting in warmer temperatures. And that, of course, means more melting, more of these moulins, and so an even faster demise.
And it isn't only Greenland's ice that's under threat. Around the world,